of all, I would like to thank IISc for giving me this opportunity to present my work. So I work on hydroclimatic extremes, how these hydroclimatic extremes are changing under the anthropogenic climate, especially under the climate change and region-specific human activities. So before going ahead, we should know about the hydroclimatic extremes. What are these hydroclimatic extremes? So basically hydroclimatic extremes are hydrological extremes and climatic extremes where we focus on hydrological extremes of flood, drought, or climatic extremes like extreme precipitation, heat wave, cold wave. So basically these extremes are deviated from the typical normal weather or climate. If you see here a normal distribution of any extreme, so basically we focus on the lower tail and the higher tail of the data set. So if that is in the lower tail, basically we focuses on the cold wave or droughts. If it is on the higher tail, we are focusing on the heat waves or floods. So and basically these extremes have very low probability. So when we design an infrastructure or when we do some assessment on the some sectors, maybe agriculture or energy or ecology or maybe the human health, that time we focuses on these low chances of the extremes. Those can occur over region. So hydroclimatic extreme, today we will focus on the extreme precipitation, flood, heat wave and drought. And these extremes pose significant impact on water management or water resources, food or agriculture, over energy infrastructure and renewable energy generation, over ecosystem, forest fires, human migration and the human health. So before we discuss about the impact of climate change and human activities on hydroclimatic extremes, first of all we should know why these hydroclimatic extremes occur. It is not like these extremes occurring recent days. Those are occurring like hundreds years ago, like the starting of the earth. So during the starting of the earth, or maybe the without human intervention, these hydroclimatic extremes normally have some specific cycle. So if you see, this is the temperature cycle of earth in the past thousands of years ago. So here you can see there is a natural variability in the temperature as well as in the CO2 emission. But in the last few years, we have seen the significant increase in the temperature and the emission of the CO2 emission, and that pose significant impact on the characteristics of the hydroclimatic extremes. But during the without human influence, why there is this natural variability in the occurrence of the hydroclimatic extremes or the temperature? That is basically due to the natural variability, the variation of the orbital distance between the earth and sun, and the volcanic eruption and solar cycle on the earth. And due to that, these phenomena, natural variability, there is also one major driver of these hydroclimatic extreme, that is El Nino southern oscillation, that is basically the warmer temperature condition in the Pacific Ocean. And due to this warming Pacific condition, it affects the wind condition and the monsoon over the different parts of the globe. So when we have the warmer condition in the Pacific Ocean, the Indian subcontinent receive very less rainfall, and that affect our Indian summer monsoon. And these INSO effect have like the occurrence of like 2 to 7 years, and it has 3 phases: warm phase, cool phase and the neutral phase. So when it is in the warm phase, there is a deficit in precipitation over Indian subcontinent. When it is in cool phase, then there is a surplus rainfall in our Indian subcontinent, or we receive more floods or extreme precipitation. If there is a INSO warming condition, then there is a drought or heat wave over the Indian subcontinent. But due to the human intervention or human activities over Earth's global temperature, or due to the global warming, the temperature has increased in past 100 years, and due to that there is a changes in our hydrological cycle. There is an increase in the atmospheric water demand that now can hold more amount of moisture or water in our atmosphere. Due to that, they can cause more amount or extreme amount of precipitation, or maybe the severe amount of droughts or flood. So that we have also like experienced in the recent past. In every year we see heat waves, flood or drought, and many studies has reported that these type of hydroclimatic extremes has significantly increased in the past 10 years compared to the reference level of 1982-2010. And due to that, there is a significant impact on our socio-economic condition. So that's why we need to understand these hydroclimatic extremes, how these hydroclimatic extremes will affect different sectors, how they impact the water resources, energy sector, socio-economic condition over agriculture and other sectors, as well as how the mechanisms those cause these hydroclimatic extremes are changing under the climate change and the human activities. And as this global warming increasing, there are different scenarios, and under these scenarios, how these extremes will occur in the future. So at IIT Jodhpur in hydro monitoring lab, we are focusing on the three major aspects of the hydroclimatic extremes, and we would like to address this major scientific question that how we can develop effective adaptation strategies to reduce the risk of hydroclimatic extremes on infrastructure and other sectors. So we focuses on the impact of hydroclimatic extremes, how these hydroclimatic extremes are changing under the climate change and human activities, and how the risk of these hydroclimatic extremes are increasing on the infrastructure damage. Then we are also focusing on the processes, mechanisms and the drivers of the hydroclimatic extremes, and at the end to develop the effective resilient strategy or adaptation strategy, we should know the when these hydroclimatic extremes occur and what are the conditions in the real time. So we also need to do the monitoring of these hydroclimatic extremes. And these all three verticals are connected to each other. If we want to do the reliable monitoring of the hydroclimatic extreme, we should know what are the processes behind these hydroclimatic extremes other than the known processes. There are many processes, those are changing due to the climate change and the human activities. At the same time, we also need to understand how the risk of these hydroclimatic extremes will change as the processes are changing, and it will also affect our monitoring system or modeling techniques. So first we will discuss about the impact of climate change on hydroclimatic extremes. So due to the climate change, there is a severe occurrence of the heat wave over the Indian subcontinent. So recently in 2022-2023, we observed a mega heat waves, and these type of mega heat waves will occur very frequently in the future warming climate, and after 2040 these extremes are very frequent. Similarly, the drought frequency and the severity will also increase significantly over the Indian subcontinent, especially in the northern and the northwestern region of the Indian subcontinent. And due to these heat wave and droughts, there is also the risk of compound risk of heat wave and droughts. So previously there is less risk of heat wave and droughts occurring together, but due to the climate change, now these extremes can occur together with more severe impact on the agriculture or water resources sectors. Similarly, the extreme precipitation, since due to the climate change, moisture holding capacity has increased in our atmosphere. So extreme precipitation and floods will also increase in the future climate, especially in the central part of the India. And other than this, since we have number of global climate models, those project these climate change, and the uncertainty in these climate change are very high. So we need to provide the reliable information of these hydroclimatic extremes. If we use some bunch of the models, they may provide other kind of risk or other values of risk. If we use different set of the global climate models, they will provide different set of risk indicators. So we need to do the uncertainty analysis, and we need to provide the reliable information of the future climate, so we can design our future infrastructures accordingly. So other than that, these hydroclimatic extremes pose severe impact on our dam infrastructure. In India, we have more than 6,000 dams, and these dams are severely affected by the extreme precipitation and the floods. So in the recent years, the risk of extreme precipitation has increased, and that will pose severe impact on these dam infrastructures. Similarly, the energy infrastructure is also under threat under the heat waves. And in the Rajasthan, we can see where we have very less density of energy infrastructure, the disturbances of the energy infrastructure is more, as well as Rajasthan is famous for the renewable energy of the solar and wind, and due to the climate change, there is a significantly decrease in the wind renewable energy over the Rajasthan. So these are the few changes. These are the few impacts on the hydroclimatic extremes and different sectors of the climate change. Similarly, there is changes in the mechanism, processes, and the drivers of the hydroclimatic extreme. So one of the driver we discussed, like the INSO, there are number of drivers, Indian Ocean Dipole and the other drivers, oceanic drivers or atmospheric drivers, those affect these hydroclimatic extremes, and due to the climate change, these drivers are the processes and the impact of these drivers are changing with the climate change and the human activities. So normally we use hydrological model or land surface model to assess how these processes, drivers or mechanisms will change due to the human activities and the climate change. So for example, we use this variable infiltration capacity model. Using that, we can assess various unknown hydrological components. Those are not available and we can identify what kind of processes are dominating in a particular watershed, and those can change due to the human activities and the climate change. Air pollution concentration on hydroclimatic extremes and how they will change at different regions. So for examples, the drivers of the mega heat waves, those will change in the future warming climate. We are receiving more amount of mega heat waves even under the neutral condition of the El Nino conditions. Similarly, the industrial aerosols are also increasing the risk of droughts in the future warming climate. Other than the droughts, there are flood mechanisms are also changing. There are different flood mechanisms, maybe meteorological conditions or watershed based characteristics based mechanisms. Those are also changing, specifically due to the human activities, regional based human activities like the dam operation, irrigation, groundwater abstraction, or the unplanned urbanization. So those hydroclimatic extremes are also changing under the different human activities. So to deal with these increased risk of hydroclimatic extreme, we require reliable information of the hydroclimatic extremes. So We developed this India drought monitoring system using the land surface model, where we have not considered human influence till now, but in the future, right now we are including the future influence on. Similarly, we are developing this hyperlocal heat wave early warning system that can provide the heat wave early warning information, as well as we can reduce the impact of urban heat wave or urban heat island impact on our cities. And there are substantial human activities at a local level. So now we are including those human activities in our modeling techniques, and to understand how these hydroclimatic extremes will change in the future. And due to the effort of the scientific community and the effort from the government side, there is a decrease in the climate mortalities in the past 100 years. So previously in the 1920s, those are very high. Now due to the development or the scientific advancement, those numbers are very less. And we have developed few data sets. Those can be used by different researchers and students. Those are available at our website. Thank you.
Thank you, Dr. Saral, for a very interesting talk.
Thank you.
Apparently, the future is looking not so very bright. I think all of us have to be aware of that, I guess. Especially we burn so much of coal. 60% of our electricity is made from coal, and we are going to use more and more coal. That's what I understand, actually. So apart from that, I think it is a very interesting study. So the talk is open for some questions if you have. Yes.
You said this hydroclimatic extremes in the past has happened because of volcanic activities. Can you take
Not
that as a
only
measure?
the volcanic activity, sir. Not only the volcanic
One of them,
activity.
yeah. Solar cycles and so on. So can you quantify whatever human beings are doing to the earth in terms of volcanic activity units? Like it's equivalent to 10 volcanic activity, whatever you have done.
Okay, so
maybe a good idea.
That is very interesting question, sir. I have not done this kind of study, like how the human activities equivalent to the one volcanic activities. Yeah, but it is interesting to find out. That surely I will do.
Any other questions? Yeah.
So we have two kind of human activities: indirect human activities, those cause climate change, and there are few regional based direct human activities like the dam operation or irrigation or changes in the local water cycle. So both can influence the hydroclimatic extremes.
There is one from the fourth row. Somebody raised the third row.
I didn't get anything about what you have done in this presentation. Your own contribution has not been highlighted.
So sir, we do study of so.
I know, but this is a very general talk. There's no mention of your work.
So sir, when we do the analysis of these hydroclimatic extremes, these 3 points are very critical. The impact, how the climate change will impact the hydroclimatic extremes. So first we have analyzed how the risk of hydroclimatic extremes will change due to the climate change in the future, and we have provided very reliable projection of these hydroclimatic extremes that I have mentioned in few of my slides, that how these few models can, if we select a few models, how they can project a different kind of scenarios of hydroclimatic extremes. That is one vertical of the impact of hydroclimatic extremes. Another vertical is the processes behind hydroclimatic extremes. So we have also analyzed like how the extreme precipitation may affect the floods occurrence. It is not always possible that all kind of extreme precipitation will cause the flood. In few regions there are like one day extreme precipitation can cause the flood. There may be few regions where multi-day extreme precipitation cause the flood, and in the few regions there are few dominating areas, those can cause the floods. However, I have not discussed all the points in detail due to the time limit.
Okay.
Yeah.
His question is that you could have, presented your own studies, how these floods are going to be, multiplied or reduced, or what is the data that you have not produced? You have given a result of, which is, the academy fellows they expect and associate to present a cutting-edge research, the data, the results, which people could see here.
Okay, so I think that's a good message that you have to blow your own bugle a little bit more.
So I think with that we close this